Hello there, welcome to this video on finding trigonometric values of the unit circles. In this video, we're going to build off your knowledge of the unit circle and kind of how to find, sine of certain unit circle angles and also cosine of unit circle angles. And we're going to kind of dig into the other four trigonometric functions that you should know. Okay, so let's go ahead and start off with what are called quotient identities, right? Quotient meaning division. So you've learned that in the unit circle, the cosine and sine of the angle correspond to the x-coordinate and y-coordinate respectively, where the terminal side intersects the unit circle. So using this knowledge and your knowledge of right triangle trigonometry, we're going to go ahead and derive kind of the other third main trig function, right? So you have sine, cosine, and tangent. So over here, what we have is we have a triangle embedded, and you can see that this is x, right? That means that's cosine theta. And here is y, right? That is sine theta. So if I want tangent, right? Well, tangent, and I'll put this in kind of green here. So tan theta, that is opposite over adjacent, right? And you can see that here, opposite over adjacent. So using substitution, what we get is our identity for tangent of theta. That tangent of theta is equal to sine theta over cosine theta. And this is very, very important. I would box this, highlight this, put a star by this. You're gonna need to know this, okay? And just kind of using that idea, the idea of reciprocals, right? Tan theta is sine over cosine, so cotangent theta, its reciprocal is going to be the reverse of that, right? So cosine theta over sine theta. So we get our two quotient identities there. Now, also keep in mind here that reciprocal identities also apply to sine and cosine. So the reciprocal of sine is cosecant theta, right? So if you ever have a cosecant theta problem, it's going to be 1 over sine. And then additionally, too, if I have secant of theta, well, that's the reciprocal of cosine. Okay, so we're going to be utilizing these ideas in applying and finding trigonometric values of unit circle angles. Okay, so let's go ahead and look at some examples. Oh, and if you're wondering, like, if you should memorize this, the answer is yes. I would definitely make flashcards, right? For tan theta is equal to this, cotan theta is equal to this, cosecant theta is equal to this, secant theta is equal to this. And for sine and cosine theta, what I would tell you is I would say that sine theta is equal to y. Like, that should be a flashcard that you should make. And cosine theta is equal to x. Okay, and those are things that you should just have to be able to easily to recall, right? Okay, so we're going to go ahead and find values for the given functions, and they say use the unit circle and trigonometric identities to find each value. So I want secant of pi over 6. Okay, well, I know, right, that secant theta, okay, sorry, pi over 6, that was me hitting the brakes, okay, is equal to 1 over cosine of theta. So I want 1 over cosine of pi over 6. Okay, so I have to ask myself, okay, what is cosine? I don't want to go over there. I want to keep going down here. So cosine of pi over 6, right? That's your x value. Okay, so that's going to be root 3 over 2. Okay, and if I go ahead and I take this reciprocal, that's 2 over root 3. Well, I have to go ahead and rationalize this. Okay, so we get 2 root 3 over 3. So there's your value, 2 root 3 over 3. Okay, and it's easy. All I did was use my reciprocal identity. All right, let's go ahead and look at the next example. What is secant of 3 pi over 4? Okay, well, I know that this is equal to 1 over cosine of 3 pi over 4. Okay, so what's my x value at 3 pi over 4? Well, that would be, I know it's root 2 over 2. Okay, and 3 pi over 4, that's in quadrant 2, which makes our x value negative. Okay, so we get negative 2 over root 2, which after rationalizing or reducing, you could just go ahead and reduce. You get negative 2 root 2 over 2, which is just negative root 2. Okay, so negative root 2. All right, secant of pi over 2. Ooh, I sense something good's going to happen here, or bad, depending upon how you look at it. Pi over 2, right, that's the North Pole, so depending upon what value we get, we could have an answer that's 0 or undefined, and I'll show you those examples here. So again, this is 1 over cosine of pi over 2, okay, and your x value at the North Pole is 0. So that's going to give you undefined. Infinity, you'd have an asymptote here, right? So undefined. All right, okay. Let's go ahead and look at cosecant. So cosecant, it's the same exact idea, except my reciprocal identity is 1 over sine theta, okay? And you have to know those relationships, right? That's kind of like the meat of these problems. So this is going to be equal to 1 over sine of pi thirds. Okay, and I have to ask myself, all right, sine, that's my y value. What's the y value at pi thirds? And that is root 3 over 2. Sorry, I forget this is over 1. Okay, so I have 2 over root 3, which after rationalizing gives us 2 root 3 over 3. So 2 root 3 over 3. Okay, all right, cosecant of 5 pi over 4. Well, this is 1 over sine of 5 pi over 4. Okay, pi over 4, that's a pi fourth angle. Okay, and your y value is going to be, again, root 2 over 2, but is it positive or negative? Okay, 5 pi over 4, that's a little bit more than 4 pi over 4. That's in quadrant 3. Right, so your sine value is negative. So again, we have negative 2 over root 2, which is negative 2 root 2 over 2, which is negative root 2. I'm having like some mad deja vu on this page. This is negative root 2. All right, next, cosecant of pi over 2. Ooh, am I going to get undefined? Well, let's see. I have 1. This is 1 equal to 1 over sine at pi over 2. Oh, good news. What's the y value at pi over 2? 1. So I have 1 over 1, which is just 1. So the answer is 1. Okay? All right. So that's it. I mean, that's easy. Okay, here are some practice problems. I want you to pause the video. Please try these. Pause them. Let me know what you got. Try to test your memory skills. Can you do this without? Can you use the left-hand trick? If you're in my class, you know what that is. If you don't know what the left-hand trick is, if I don't have a video on it, then you can just YouTube it. Left-hand trick, that's really great for memorization. Okay, so pause the video. Try it. All right, here's the solutions. You should have gotten secant of pi fourths is root 2, and secant of 7 pi 6 is negative 2 root 3 over 3. Okay, here is another set. I want you to go ahead, please try these. Okay, hopefully you tried these. Here are the solutions. Can you get these values? Undefined, right? 1 over 0 is undefined. Do not put no solution. It's undefined. There is a solution. It's just undefined. All right? All right. Next, what I want to go ahead and do is I want to talk about tangent and cotangent theta. So it's very, very important that you use your initial idea here, right? That tan theta is equal to sine theta over cosine theta. Now, people say, how do you remember that, Schwarberg? Well, tan theta, I just think about it's the first function in SOHCAHTOA divided by the second function in SOHCAHTOA equals the third one, right? So sine theta over cosine theta is tan. All right, so I have tan of 3 pi over 4, and I want to go ahead and solve this. So I'm going to rewrite this as sine of 3 pi over 4 divided by cosine of 3 pi over 4. Okay, so it's important to note, right, that 3 pi over 4, that this is quadrant 2, right? So my sine value is positive, so this is root 2 over 2. and my x value is negative root 2 over 2. Okay, so I have something divided by itself. The answer is 1, but one of them is negative. Positive divided by negative is negative 1. Okay, all right. Next example, tangent of 7 pi over 6. All right, so I know that this is, again, sine over cosine. So 7 pi over 6. This is just past 6 pi over 6, right, which is pi. So this is going to put it in quadrant 3, where everything is negative. Okay, and my y value is negative 1/2. My x value is negative root 3 over 2. And I have a fraction divided by a fraction. All right, so here's what you do. Obviously, I mean, the negatives cancel out. I'll keep them just so I don't throw you off. So, woo! Negative 1/2. Screen trips me out when it moves. Okay, so I get negative 2 over root 3. How do we divide fractions? You multiply by the reciprocal of the denominator. So flip the denominator and multiply. Okay. All right, so our 2's cancel, the negatives cancel, and we get positive 1 over root 3, which after rationalizing is root 3 over 3. Okay. All right. Lastly, on this example, we have tan of pi halves. Okay, again, tan is sine over cosine. Okay, pi over 2, that's the North Pole. Your y value is 1. Cosine, your y value is 0. This is undefined, folks. Sound so old-fashioned. Folks. Undefined. There you have it. Tangent, sine over cosine. Don't forget it. All right. Here are some practice problems. Please pause the video. Try these. Okay, hopefully you paused. Here is the solution. There you go. Okay. All right, lastly, we have cotan theta. So same idea. Okay, cotan theta, it's the reciprocal of tangent. So this time, it's going to be cosine theta over sine theta. Schwarberg, how do we remember this? To me, I see the word cotan theta. I'm going to have cosine on top. That's just my memory trick, okay? Let's go ahead and apply this. All right, so cotangent of pi 6. Okay, I know that cotangent is cosine over sine. Okay, so I want my x value on top. Okay, pi 6, that's root 3 over 2 divided by 1/2. Okay, everything's positive. We're in quadrant 1. Everyone's so positive in quadrant 1. I just love everyone in quadrant 1. Everyone's so nice. Okay, we get root 3. Easy. All right. Next one. Cotangent of 5 pi over 3. Okay, cosine of 5 pi over 3. Schwarber, this is so easy. Good job. I'm glad this is easy, right? You just need to know your identities. Flashcards will totally help you out with this. Okay, cosine of 5 pi over 3. Again, this is a pi third angle in quadrant 4, right? It almost makes 2 pi, 5 pi over 3. So 2 pi, or it would be 1 back. So we're in quadrant 4. Cosine's positive. So that would be positive 1/2 divided by negative root 3 over 2, which is 1/2 times negative 2 over root 3. 2's cancel, and we get 1 over root 3, which is root 3 over 3, and it's negative, Schwarberg. Negative root 3 over 3. Okay. All right. And last but not least, cotan of pi over 2. So cosine of pi over 2 divided by sine of pi over 2. I know that this is 0 over 1. Answer is 0. Okay, that's it. All right, pause the video. You know the drill. Oh no! I showed you the answers. Here you go. You didn't see that. Here, pause the video, try these ones on your own, and then I'll show you back the answers. All right, hopefully you've tried the examples. You didn't just peek. Here you go. Now you can peek. All right. That's it. That's finding trig values of the other 4 trigonometric functions. Hey, hope you enjoyed the video. Catch you next time. Be smart, be easy.